All right, guys, this is 9.3. We've done arithmetic sequences. Now today we're going to do the geometric sequences. So the first thing that is different with a geometric sequence versus an arithmetic sequence is a geometric sequence has what we call a common ratio. And you're going to see that as the letter R in the formulas that we use. And it's just the ratio of a term to its previous term. It's the second term divided by the first, or the third term divided by the second, and it will be a constant. In other words, it's a number that doesn't change throughout the formula. So the way we figure out what R is we take some term, a sub n, and we divide it by the term before that, right? A sub n minus 1. So I'll show you what that looks like in just a minute here. But that's how you're going to find your common ratio. So this first example, it asks, is the sequence arithmetic, geometric, or neither? And if you look here, from 5 to 10, from 10 to 15, from 15 to 20, 20 to 25, you have to ask yourself, is there something I'm constantly adding or something I'm constantly multiplying by to get to my next term? If you can't find it, you start with this term and go to this term. So try 10 minus 5, 15 minus 10. 20 minus 15. If that doesn't give you something, then you divide. 10 divided by 5, 15 divided by 10, 20 divided by 15. This one works with the subtraction. If I go 10 minus 5, I get a positive 5. So that means I am adding 5 each time. Okay, and you can see that continues all the way through. So if I'm adding, that's an arithmetic sequence where our common difference is 5. Okay, it's whatever you're adding each time. If you look at letter B, it starts out very similar, right? 5, 10, but now it says 20, and then 40, and then 80. With that one, we would add 5 here, but now we add 10. Okay, that's not constant. That number is changing. So we don't want to do that. Instead, check with division. I can do 10 divided by 5, and I get 2. I can do 20 divided by 10, and I get 2. I can do 40 divided by 20, and I get 2, right? So this is my common ratio. It's the number divided by the number right in front of it. The number divided by the number right in front of it. So this, because you have a constant when you are dividing and multiplying, we say that is geometric. And then your common ratio, that lowercase r, like we saw up here, is going to be whatever that number is when you divided the term with the term before it. So our common ratio here is 2. Okay, excuse me. Letter C here, if you look, let's think about adding and subtracting. So if I go 2 minus 1, that's 1, right? We would be adding 1. 6 minus 2 is 4, so we would be adding 4. This one we'd be adding 1. That is not constant. That is changing. So we know it's not arithmetic. We're not adding the same thing every time. So then you check, is it geometric? Well, 2 divided by the term right in front of it is 2. 6 divided by the term right in front of it is 3. Again, that is not constant. It's a different number. So if it's not adding the same thing and it's not multiplying the same thing, then we would say this is neither. Okay. Okay, so we did some formulas with arithmetic sequences. We're going to look at the formulas that get used with geometric sequences today, since that's the sequences we're talking about. So I laid those formulas out here for you. And it's very similar. It's just geometric instead of arithmetic. So you still have your A1 is your given value, your first term. All right, this will be your first term, and that will be given to you. And then A sub n is going to be equal to your A sub n minus 1, so the term before it, times your common ratio. Okay, so that's the recursive formula. The explicit formula takes your first term, A sub 1, and your common ratio, and multiplies them. Once you take, so you got to do this part first, your common ratio to the n minus 1 power. So whatever term number you're looking for, if you're looking for the 6th term, you would take r to the 6 minus 1, so r to the 5th. Okay, and then you can multiply by your first term. So let's try some of those out. Look at example 2 here. You have 11, 33, 99, 297, and it says write the recursive formula. And they'll tell you typically on these that it's a geometric sequence, but you can also check it, right? 33 divided by 11 is 3. 99 divided by 33 is 3. And 297 divided by 99 is 3. So you can see that it's geometric because you divided and you got a constant, okay? That means for the recursive formula then, a sub 1 is your first term. So in this case, that's 11. And then a sub n, and it always starts this way, a sub n minus 1 times something. And we already found what that something is. That's our 3. We were multiplying by 3 all the way through. So that would be your recursive formula. Okay, then it says write the explicit formula. And now we're looking at this guy right up here. So it's going to be a sub n equals our first term, a sub 1, right? Which again, that was 11. That was given to us. Times our common ratio, which again, we already found was the 3. And then to the n minus 1 power. So that would be your equation for the explicit formula. Then it says, what is the 10th term of the sequence? Now, when you're finding a recursive or using a recursive formula, you have to know the term in front of it, right? So if I'm going to use that, I have to find the 10th term and the 9th term and the 8th term and the 7th term and the 6th term and so on and so forth, which you can do, right? I can go up here to my 297, I can multiply by 3 and get my next one, and then I can multiply by 3 and get my next one again, and I can multiply by 3 and get my next one again. It's going to take you a long time. Usually when they ask you for some number of term, you just plug it into the explicit because that is your n that they gave you. So the 10th term, you would say a sub 10, the 10th term, equals 11 times 3 to the 10 minus 1 power. So what you're plugging in is 11 times 3 to the 9th power. Okay, make sure you don't do 11 times 3, 33, and take that to the 9th. You want 3 to the 9th, and then you can multiply by 11. So we get the 10th term here, when you plug that into your calculator, comes out to 216,513. Okay. Moving on. Example 3 here, it says write the recursive formula, write the explicit formula for negative 1,000, 100, negative 10, and 1. Okay, like I said, the recursive formula, we're just using this stuff still. Okay, so we're going to do a sub 1, in other words, your first term, which is negative 1,000, and then a sub n is going to be our a sub n minus 1. Okay, that's always the way it starts, a sub n minus 1. And we're multiplying by our common ratio. So again, we need to figure out what that is. The way we do that is we take the second term and divide by the first term. So 100 divided by negative 1,000. Okay, if we simplify that, that is negative 1/10. Or take this one, negative 10 divided by the one in front of it is 100. Simplify that, that's negative 1/10. Or even better, use these two. 1 divided by negative 10 is a negative 1/10, right? So you get your common ratio here is a negative 1/10. We would be multiplying by negative 1/10 each time. Okay, so that's the recursive formula. The explicit formula, again, we're just using this setup right up here, and we're going to say a sub n equals our a sub 1, which was the negative 1,000, times the common ratio, which is a negative 1/10, and we take that to the n minus 1 power. Okay, so that would be our explicit formula for that one. Okay, this one, they give it to us a little bit different here. It says write an explicit geometric formula. Okay, so those words should take you again right to here. The explicit geometric formula. Okay, so that's the type of formula we're trying to write. I will just write that off to the side here so you guys know what I'm talking about. It's this setup, right? That's what we're trying to fill in. So think about what they gave us. It says a sub 1 is 2. Okay, so we're going to say a sub n equals 2 times, and they gave us the common ratio, 10 to the n minus 1. Okay, so it asks us find the first 5 terms. Here's our formula. Now I can say a sub 1. Now don't do the extra work here. You could plug a 1 into the formula. You don't need to. They told you what a sub 1 was. It's 2. A sub 2, we would plug a 2 in. So this is 2 times 10 to the 2 minus 1. Well, that's just 2 times 10 to the first power, which is 20. Okay, so there's our first 2 terms. A sub 3 is going to be 2 times 10 to the 3 minus 1, or the second power, which is 200. A sub 4 is going to be 2 times 10 to the 4 minus 1, so the third power, 2000. And a sub 5 is 2 times 10 to the 5 minus 1, which is the fourth power, and that's 20,000. Okay, so when they ask you for the first 5 terms of the sequence, it's 2, 20, 200, 2,000, 20,000. Those are your first 5 terms. Okay. Okay, last concept that we're going to talk about is called geometric mean. And we talked about the arithmetic mean. Remember, with arithmetic, we were adding. Okay, so it was take the 2 numbers, add them together, and then divide by 2. Well, with the geometric mean, we're multiplying. So we're going to multiply the 2 numbers, but then instead of divide by 2, we take the square root of them. Okay, so you're taking the square root of the product of 2 numbers is essentially what you're doing. But same as saying the square root of x times y, okay, whatever those x and y numbers are. So if you look at number 5 here, it says, what is the value of the missing term in the geometric sequence? So we know it's geometric. We are essentially here finding the geometric mean. So we're going to take the square root of the product of those 2 numbers. So 20 times 80. And you can plug it into your calculator like that. Just make sure you don't take the square root of 20 and then multiply that by 80. We want the square root of 20 times 80, which would really be the square root of 1600, which is 40. So your answer here should be 40. Okay. Now this one's a little bit different, but again, there's 5 numbers here. We're going to find this one first because that's the one that's perfectly in between the 2 that we're given. So we're going to take the square root of 19,683 times 243. Okay, if you plug that in, you will get 2,187. So that's this number. Okay, now we're going to do it with those 2. So we're going to take the square root of 19,683 times 2,187. Plug that into your calculator, and you should get 6,561. So that goes there. And then the last one we're going to do with these 2 numbers. So it's going to be the square root of 2,187 times 243. Plug that into your calculator. You get 729. Okay, that is your 9-3.